The first set of directions end up asking us to determine whether each event is impossible, unlikely, as likely as not, likely, or certain. And so when we take a look at the first problem here, it says rolling a number less than 4 on a number cube labeled 1 through 6. Well, before we get to that problem, let's just go over once more what a probability looks like here. Remember we said probability, the notation that we'll use is P, capital P stands for the probability of an event. And the event in this case would end up being rolling a number cube less than 4, and then that's what we want to put down as our event. We'll do that in just a moment. Well, the fraction form of this probability, how we get these numbers up here, and then from the fractions we can write them as decimals or percents. The fraction form goes the number of successes, so number of successes on top of the fraction, and then we have the total number of outcomes, on the bottom of the fraction. And so that's what we're looking for. Number of successes on the top, total number of outcomes on the bottom. So as I look at this one, we are asked to find the probability of rolling a number that is less than 4. And so note the numbers that we could possibly have. So let's write down what our successes would be. A success would end up being rolling a number of 1, 2, 3, and then that's it. We can't roll a 4 because it has to be less than 4. It can't equal 4. So these are the only numbers that are successes. So 1, 2, 3, or 4. So there's only 3 numbers that are successes. 3 out of how many? Well, it's on a number cube that's labeled 1 through 6. So the total number of outcomes we could have would be, so we'll say outcomes total would either be a 1, a 2, a 3, a 4, 5, or a 6. So there are 1, 2, 3, 4, 5, 6 different outcomes. So we reduce that fraction and we're at 1/2. So 1/2 is right in the middle. And so that is the only one where you're going to say as likely as not. And so if it's right in the middle, that's 50%, 0.5, 1/2. That means that it's going to be as likely as not. Anything on either side would either be unlikely, likely, impossible, or certain. Taking a look at the next one, it's picking a card with a multiple of 3 from a box with 10 numbered cards, numbered 1 through 10. So let's list the ones that would be good. Ones that are multiples of 3 would end up being numbers like 3 itself. We could have a 6, that's a multiple of 3 because 3 goes into that number. Or you just count by 3's here, 3, 6, and the next one would be 9. So these are the different outcomes that are good. These are the successes. So our probability of selecting a multiple of 3 would end up being, our first top of the fraction would end up being 3. The bottom of the fraction, well, that's numbers 1 through 10, so there's 10 total. So this is our total, so that's why that goes on the bottom. And when we look at this fraction, this would be the same thing as 0.3 or 30%. And so when we have a number that's less than 50%, we would say it's an unlikely event. So it's probably not going to happen, but it could happen. Definitely could. It just doesn't happen as often as ones that are not multiples of 3. Drawing a red marble from a bag of 3 blues, 8 reds, and 2 greens. Alright, well, we want to draw a red marble. So how many red marbles are there? Well, there's 8 reds. So the probability of a red would end up being 8 over how many are there? Well, there's 2, 3, and 8. So you add those numbers up, 2 plus 3 plus 8. Well, that adds to equal 13. And so we have 8 over 13. And this is greater than 1/2. Half would be if I had a 7.5. So it's just bigger than 1/2. And so I would say it is a likely event. And again, it's a little bit bigger than 1/2. We'll say bigger than 1/2. And so that's why I went with a likely event. Well, let's take a look at the next one. rolling a number cube that has sides labeled 2, 4, 6, 8, and 10, or 12, and we want to get an even number. So the probability of an even number. Well, in our case, everyone is even. 2, 4, 6, 8, 10, 12. There are 6 even numbers, so there's 6 possible events that could occur. 6 successes out of how many? Well, there's only 6 different numbers on the number cube, and so that would equal 1. So this is a certain event. It will happen. So that's what we end up with. Picking 2 cards that have a sum of greater than 10 from a set of number cards in which there are 3 4s, 5 3s, and 2 5s. It's best to list these numbers and see what we have here. So let me list the numbers that we have. So we have 3 4s, so I'll list 4, 4, 4. Those are the 3 cards there. And then we have 5 3s, so 1, 2, 3, 4, 5. And then we have 2 5s. So let's see what they want us to do again. These are the different cards we have. We want to pick 2 cards, so only 2 of them. And the sum has to be greater than 10. So we're looking for the probability of something greater than. So it's open to what I'm talking about here. So greater than 10 is what we're looking for. And so what numbers could we add together to make something bigger than 10? You see, 4 and 3 would make 7. 4 and 4 would make 8. 5 and 3 would make 8. 5 and 4 makes 9. 5 and 5 makes 10. But that's not greater than 10. None of those are greater than 10. So the probability of success would be 0. We have no successes. Over how many outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 outcomes, but there's 0 successes. So this is an impossible event. So it's definitely not going to happen because there's no way of getting numbers greater than 10 if I'm just selecting 2 cards. Drawing a yellow marble from a bag of 5 blues, 2 greens, and 7 yellows. Well, we want to draw a yellow marble, so we want the probability of drawing a yellow, so Y for yellow. And how many yellows are there? Well, there's 7 yellows. How many total marbles are there? Well, let's add them up. We have 2 plus 7 plus the 5. So that adds to make 9 plus 5 makes 14. So 14. So 7 over 14, well, that makes 1/2. Whenever the number is going to be 1/2 or 50%, that's as likely as not. So those are similar to your first few problems on your homework. Part 3 will have the rest of the problems.